some years ago, I acquired a TI-88. And I don't remember, quite frankly, how I did so. I did bring it to one conference, and I showed it around. I think maybe Gene saw it at that time. He says, you know, Richard, if you ever want to get rid of that, I want to be the first one on the list. So over the years, and a lot of complicated details, we worked out a deal. And when I moved to Arizona in 2007, I retired and moved to Arizona. I apparently took the battery out of the TI and put it into a bag, and then it got lost in the move. Last year, I found the bag, and the cover was with the battery. And I wondered why was, if I had a leaky battery, why was the cover in there? Oops. Anyway, here's the TI. And since Gene was eventually going to be the new owner of the machine, his name is in there. And in your proceedings, you do have also a copy of the image of the machine, but this is one that I took. And some of the memorable features, and I don't want to step on Gene's thing here, but is the yes-no key and the red key. But they are unique features. So I thought I removed the leaky battery, but turns out that the battery clip holding, contact from the circuit board, making the contacts, those little things had broken off. And there was no marking of the polarity. And so if I'm going to try to make this machine work again, after bringing storage and what have you, moving and all of that, I didn't want to just make a guess and take my power supply and apply power to it, because this was not, I couldn't replace it if I destroyed it. So I went through a very long analysis trying to figure out what that polarity was. And it was a challenging problem, which you say, oh, well, you just take this lead, you follow the circuit all around, and you find a capacitor that will be marked, and now you know the polarity, or a diode, or something like that. And so in 2018, Bob was visiting. Bob has a number of interests besides tanks and calculators. He also is a very avid NASCAR fan, and so he was coming out to Arizona to watch some of the races. And so, we're kind of a small community. We know what each other's doing and what have you. And so Bob says, well, let's get the 88 going. And we powered it up, and it was working. So here's part of the hardware here. Here's one battery contact, and here's the other one. The lighting is different on the reflection. And you can see you have a normal circuit board. Here's a diode sitting here. So there's parts on top of a board. So once I had figured out, and I'm skipping over a lot of the details here because not all of you are hardware electronics types. And So now that once I had determined the polarity, and of course Gene's happy and he's starting to get anxious for it. How are we going to power this up? And some of my first ideas was, well, you know, one thing is fairly common, but it's changing now, is a USB. We all have USB adapters and cables and connectors and all of that. I'll just put a USB female connector on the back of the machine, and then you can plug it into USB, and that can work. And it turned out there is one particular integrated circuit as a regulator that will go down to 1.2 volts. And so that, and it was small, really tiny, so space is not the problem. And I talked with Gene because, you know, he's the one who's going to be using it. And so we came up, well, let's just put a battery holder inside. And the one that was originally in there was a AA size. And however, if I'm going to add to that another battery holder, all that adds more physical dimensions. And so a AA cell wasn't going to fit, but a AAA would. And so with a AAA, common cells are 1.5 volts for alkaline, and a rechargeable for a 1.2 volts. So I used sticky tape and AAA battery holder to replace the broken prongs. Now, one of the important parameters, see, when you have a calculator and you press the on button and nothing happens, now what do you do? I mean, there's not, it's pretty hard to say, well, something's wrong and how do I troubleshoot this? But one of the key parameters with any integrated circuit is to measure its current. Its quiescent current and its operating current under various conditions. So since I was running this by a power supply, I could, you know, see what's going on.
Did you figure out the polarity?
Yes, I did. Oh, and the way I did figure that out was there's two cartridges that plug in, and I researched the internet and found some polarity markings on one of that, and knowing the polarity on the pin of the cartridge and matching that up with the circuit board, I was able to trace that back and get the polarity. Now, one of the issues, and again, my 2012 presentation on measuring HP calculator current discusses the issues of doing that, and I have a very good multimeter that is meets the requirements, because when you take a 1.2 volt calculator and you put a meter in series with that to measure a milliamp of current, you now have a problem that the meter resistance is high. You know, the calculator may not even turn on.
With multimeters, that's called burden voltage, and that's a big problem. When I needed a multimeter for measuring current in the calculator prototypes Rich Otteson and I built, I got a bench meter, and I had to get a fancier 6.5 digit bench meter, but fancier than the normal one, because it had lower burden voltage.
Oh, I've got a meter you're gonna love. I'll bring it down, in fact I'm gonna show it to Jim. I'll bring it down and show you the meter you gotta have. It's only $25, it's a full 4 digits, it's incredible. All right, so we've got the polarity, we've decided on the power source, and I did make some current measurements because Gene is saying, send it, you know, I want that. So I thought, well, I want to study this a little bit more, but you know, it's not that critical. But I did make some measurements, and here they are on a table, and this is taken from the paper that's on the USB drive. Well, when you just turn the machine on, it's about 0.9 milliamps. And the famous prompt, "May I help you?" Maybe adding the more characters in the display. You know, you're getting down, and again, in measuring with this current, even with a 4-digit meter, your resolution at the bottom end of the scale limits you. So I can't get 4 digits of current at this range. So it sits in here, and pressing and holding any key is one of the highest currents, and this is characteristic of all calculators pretty much, and certainly of all HP calculators, simply because of the circuitry, addressing the key and what have you. So that was 2.3 milliamps. Pressing off by flipping the switch in the power supply, not by turning the machine off. So it's instantly 0 applied voltage. It slowly decays, which would be indicating that there's a storage capacitor involved there. And then just all, loading the display and all 8s in the display. The real highest current was pressing the certain functions of store, and then there's an incomplete. It's waiting for a second key press. Go to or op code. That was in the area of 4.1, 4.3 milliamps. The audio sound, Gene is a young whippersnapper, and so his ears are better than mine. I couldn't hear it, but Gene can hear it. Okay, inside, this photograph is not one that I took because I'd already shipped this. When I prepared this, I shipped the machine to Gene, so I just couldn't go take a picture. This is one of my photographs, and I soldered the leads on there to power it. This is the what I call a bender. Has anybody in here ever heard that term bender? You know what a bender is? Bob. Bob?
I think I learned it from somebody named Richard.
Okay.
Yeah, that's where I
All right. When I was a kid, that's what we knew it. But this piezoelectric high-pitched alarm sound is an acoustical piezoelectric sound generator.
Richard, before you get too far away from the beginning, I have a slightly different recollection of the process that day. I think Richard's memory is impaired by the attempt to keep the integrity of electrical engineering. When we took it out that day, he said the right way to do it is to get a bench power supply and connect the leads up and increase 1/10 of a volt and see what happens and go up at it that way. And I said, I think the way to do it is to get a AA battery and some tape and put it on the leads and hold it and see if it works. And it did. We then went to plan B, but it's not always the, but I had the luxury, and he had already figured out the polarity, so the hard part was done.
Yeah, and I'll expand on that in just a second, okay? So, it's not a bender. If you go to Google and type in bender, they're going to talk about having too much alcohol and a whole bunch of other things, but no acoustical device is called a bender, so it's an acoustical transducer, and I removed it because there was double-sided tape sticking down on the integrated circuits underneath here. I guess as you can't quite see them, just to hold it in place, and that's the way a lot of calculators are built. And so I had clearly a made in Japan and a part number, and I could not find any information about it. So acoustic transducer uses, as they're using calculators, you can hear it. If you take the covers for the cartridges out, put it up to your ear, you can actually, two-tone alternating sound. And I couldn't find the specifications, So I couldn't do any more investigation into that. So the question is the TI-88 rare? I talked to, what's the data math?
Georg.
Who?
Norton.
I talked to him and emailed him, and I guess from his experience, which is probably greater than anybody else's, really, there's probably less than 50 in existence, and 25, less than 25 are known. And in my paper, I have a reproduction of the current list on his website as of May when I prepared this. Now, what I've always told people when manufacturers came to me, HP and TI, actually National, when they tried to get into the business, and I always told them that if you do any work for a manufacturer, don't return the prototype until you get what was promised, you know? So maybe I did something and I had one, I don't know. Certainly when projects are canceled, the money stops, you know. And again, using our experienced website, his number is that the current selling price is $1,200 to $2,000 if you can find one, and there are a lot more buyers than sellers. Now, I thought that the $350 suggested price was high, but I remember the 41CX was what, $325? You know, so, okay. In conclusion, the real challenge was figuring out the polarity of a 40-year-old calculator, realizing that one little misconnection and you've destroyed, you know, a treasure. And I didn't want to remove the motherboard. Again, disturbing, oxidation, and cleaning all that. You just create headaches that you don't necessarily want to have to deal with. And as I mentioned, the polarity was determined using the cartridge contacts. And I did do the current measurements, and I have the data in the paper, where I started out at 1.2, 1.25, 1.3, and I'm monitoring the current, and it's holding steady. So the regulation, the TI and the circuitry involved was very good, and I saw no indication that a 1.5 alkaline cell would be a problem for operating it. And of course, Gene has been using it, and we're going to hear about those results this afternoon. Are there any questions? Yes, Payne.
What is likely to break if you have the wrong polarity? What would break? Like,
What damage would you do if you connected it wrong?
yeah, the polarity.
You damage the integrated circuits.
Well, generally, any battery-powered device, be it your watch, your phone, or what have you, in the last maybe a couple of decades at least, the engineers designed it that if you put your battery backwards, it doesn't damage the device. But and there's a couple of different ways you can do that. The simplest is usually a cost thing because they're trying to reduce cost of any design, would be put simply a series diode. So if you reverse the polarity, the diode doesn't conduct, it doesn't work, and it doesn't damage. But at 1.2 volts, you can't use that method. Even if you use a germanium diode and you select it at 0.2 volts forward voltage, it's still gonna be a factor of a 1.2 volt supply. You now drop from 1.2 to less than 1 volt. But if you do reverse the polarity and it's not protected, you blow out circuits. Now, maybe not an electrolytic capacitor, because they're going to be much higher voltage, 5 volts at least. That's probably less of an issue. Although you could, leave it on there for some time, that electrolytic capacitor will not be happy of reverse polarity. So the answer to your question is you damage your circuit if it's reverse polarity. Any other questions?
On the photo, how did you know that it was 1.2 volts?
Huh?
How did you determine the voltage?
Oh,
1.2.
Did I skip Oh, I'm sorry. Oh, here it is. Okay. This is the original. This is the, if you see these little, oops. The wrong button.
Oh, I see. It says 1.2.
Okay, see these little holes here? These fit in there, and this fits underneath this. And this is the original battery that TI had in there. All right? And then this welded sheet metal contact bends over, and the springs press against the ends here. So this is the original, and this is what I used. Now this is nickel metal NiCad, okay, and this is nickel metal hydrate, and it's an improved rechargeable type. And Gene, when I went to ship it to Gene, I was so anxious to get it off to him that somehow the battery fell on the floor. And after I mailed the package, I see the battery in the floor. And Gene says, "Well, no problem, I've got one." And you're using what, 1,000 milliampere hours?
That's correct.
Yeah. So all of my estimates of battery life in my paper and all of that type of stuff is based on this cell compared to this cell. And surely this, it's an improvement.
Oh,
Bob, huh?
what I was asking was, how did you know that it was 1.2 volts? Is the original one say?
Oh, this is standard.
Oh, because
All cells of NiCads are 1.2 volts.
it's NiCad.
Yeah.
Okay.
That was never in question.
Okay, yeah.
Richard, go to the picture of the terminals. Which one is the positive one?
This one.
Okay.
Now, and again, like I said, just to give a flavor, the details, including the fact that I mentioned that after I did that, I scratched a plus here right in the circuit board, so there'll never be a decoration again. And I have a photograph of that in the paper.
Back here.
Yes.
That beeper that you mentioned, I recognize that part. We used it on some circuits in the 80s. The piezo beeper.
Can you hear him?
Yeah, the beeper in the photograph. Go to the photograph of the beeper.
It's a Kyocera part.
The what?
He has used that product, that particular part before. Move the PowerPoint to the beeper picture.
The beeper, yeah. The vendor.
Can you go forward?
Go to the bender.
Oh, okay.
Go on a bender. Go on a bender, Richard.
Yeah.
There you go.
Okay. That's a Kyocera piezo speaker, and they actually sound quite well, but they need more voltage. It's probably the circuit's got a boost on it.
Oh, I would definitely suggest that the driver, because not only do they have to raise the voltage to drive the piezoelectric device, but they have to turn it on and off to get the tones.
Right.
Yeah.
So yeah, I can help you with that perhaps.
It may not be loud enough, but putting it on a table here, I hear it fine.
Wow.
And I'll have a sound playing in the presentation of the beeper going off.
Okay, I'll make one comment on this, and this is primarily for truck study, but when I visited Corvallis to give a presentation to HP about the PPC ROM, I think I was given the numbers in the paper, 1 hour or 2 hours, okay? So I got this room full of engineers at HP, and I went through all this stuff. And I finally got, almost reached at the very end, and I'm sweating, because I'm looking at the clock and looking at my material and looking at all these HP engineers, and here I'm trying to tell them something that, I'm trying to learn from them. And one of the questions came up for the beeper or the tone generator, the 41, and they were looking at other machines to use that. And the question was, how loud should it be? And my answer was, loud enough that it may be heard in your briefcase in the other room. And after 2 hours, that's the only thing I saw them write down.
It is not that loud.
Nothing is that loud.
Well, for the 41, we made the bender coupler, we took one of those piezoelectric things and put it in a plastic stick.
Yes, what Roger's talking about is, and all of this stuff is in the journal, I designed a whole series of methods of using the 41 to control stuff. And I take a stand, all right, and put the calculator on the stand, and inside the calculator I would wire up, there's the guy with the temperature. Move it up about 4 degrees.
Yes.
Thank you.
We've got some temperature sensitive equipment in here, so we didn't want it too hot, but the cameras. I wire in the 41, everybody knows what a magnetic reed switch is, okay? So I take a miniature reed switch and wire it in there, and I would connect it across the E key. All right? A, B, C, D, E on the 41. Then on the stand, I would put a solenoid coil that I could control, so that I had another device. I think at the time I used a whistle switch. Everyone know what a whistle switch is?
Remember, you had one at the clubhouse.
Oh yeah, it's a sound activated AC switch, and they gave you a little plastic thing that just squeezed, and it had a whistle. So you could squeeze that, it would make the sound. The sound would be picked up by the AC relay, all right? You've heard of the clapper? Same idea as a clapper, but it was a whistle switch. And I gave a presentation to the U.S. Navy down in San Diego, and I used that as a presentation, and I walked around the room, and I could control my 41 by squeezing. Yeah. Are we on time?
I want to point out something real quick. You got the first one, laser. Okay. While that picture's up, these 2 rows right here are the contacts on the motherboard that allow you to have the RAM and ROM chips plugged in. The cartridges plug in under these sliding covers, that's over these, and these are at an angle propped up, okay? Terrible design, because with the version even Richard has in anything earlier, if you have anything plugged into these and you plug the printer in, it fries anything connected to that. Power goes through those prongs on its way through everything and will fry modules, which are irreplaceable. There's more machines than there are modules out in the wild. Unless you modify up here and add in a couple of diodes, and Georg has that on his data math site, which I have not wanted to do. I keep a printer in the other room because I'm terrified that in my sleep I'll try to connect it and fry something. But that's important for this. These guys pry open right there.
Gina.
Yeah, in my paper, I have more photographs, lots of photographs, and I show the case. And so HP made a great excessive design to guarantee the polarity of plugging in the printer and the two or three other things, AC adapter and so forth. It's very critical, the polarity, and the voltage, because
Richard may not remember when he got it or where, but he did cover a lot of material on the 88 in the PPC journal at the time.
I did.
There's like 10 pages of material, including TI press releases. I suspect TI sent it to him since he was the HP guy, saying, hey, here's what we got coming. And the date of the 88 is right before CES, when it was manufactured, mid-May 1982. The manual that Richard gave me is a beta version of the manual with his handwritten comments in it. This is stupid. Or, or where they had a little program in AOS, and he wrote a 41C program version below and noted how much smaller it was. So I know it's his stuff. That scan of that manual with his comments is also on your thumb drive. So I suspect he got it in about May of '82 is my best guess.
Wow. Gene, question that it looks like the connectors are both on the left side as opposed to both of them are in the center. Do the modules not plug in?
No, they plug in leaning that way.
Yeah, that's weird.
Well, anything about the 88 is weird, and Gene's gonna.
But just from a human factors, you would think that they would go in opposite ways, right, to plug in.
Dave Ramsey's next, I think.
Yes.
Where's the calculator?
Dave, are you ready?